Good morning to everybody. My name is Dr. Shantram Rai of the Department of ENC Institute of Indian Technology. Today I am going to give the introduction about the states variable analysis. This is the fifth module of the control system of the fourth semester ENC students. Before going there, some of the basic definitions you should know. Then we will go for the why it is state space analysis required. First one is state variable. What do you mean by state variable? Any system, if you want to explain that, there are some variables are required. For example, particular system having 4 to 5 variables, all the 5 variables may not be required to explain that system. Out of the 3 or 4 may be required. Therefore, the state variables are the minimum set of variables whose knowledge at t is equal to 0 along with the input u of t known sufficiently for t is greater than or is equal to 0 and completely describe the behavior of the system. This is called a state variable. Coming to second definition, state vector. The combination of all these state variables, what I explained, the previous definition is nothing but state vector. For example, out of 5 variables, there will be 3 or 4 may be sufficient to define the particular system. The corresponding set of vectors is called state vector. That's a vector whose elements are the state variable. Coming to space, anything can be defined in terms of dimension. Suppose there is a particular system with 2 variables, nothing but 2 state variables, then 2 dimensions. Therefore, depending upon number of state variables, any system can be represented in state space, nothing but n dimension whose axis are the state variables. Coming to why you have to go for state space analysis. Basically, there are so many problems you are facing when you are going with the basic system, nothing but transfer function. When there is a multiple input, multiple output, it is very difficult to solve the system by the use of the transfer function. For example, second order system, nothing but 2 input, 2 output, okay, is no problem, you will get 2 cross 2 matrix. But when you are going with the beyond that, it is very difficult to solve the matrix form, so that the state variable analysis is well suited for multiple input, multiple output system. Second one is for time domain behavior, especially for nonlinear system, it is very easy to solve by the use of state space analysis. Similarly, state equation highly compatible with simulation, analog and detailed computer system. Now, earlier days we are directly building the hardware system by designing certain system, but after that there may be changes may be required so that we are damaging so many components. Instead of that, now we are going for simulation. In simulation, by the use of state model, it's very difficult to solve or to find out the corresponding element, especially for analog and detailed computer systems. Then coming to next advantage, can be used for find the stability of the especially negative feedback system. Most of systems are negative feedback system. That will be very easy to go for the negative feedback system. Then coming, what is the state model? State model is basically the combination of 2 equations. One is called a state equation and second one is called the output equation. What is the state equation? Basically, state equation is defined by the x dash of t is equal to a x of t plus b e of t, where x of t is the matrix of the state variable. That means, for example, particular system there are 3 state variables x1, x2, x3. The matrix of that, nothing but it's a column matrix. The column matrix of that is called the state variable, that x of t, that is x1, x2, x3. Similarly, coming to A is the matrix of the coefficient of that state variable. Nothing but is called as the system matrix. It gives the actual information of that system. It is nothing but coefficient of this state variable and is called as the system matrix. So, U of t is the input where there may be again n number of the input, U1, U2, U3, again the column matrix. Coming to B is the matrix coefficient of that input variable. The order of that matrix depends upon the number of the input variable. Therefore, there will be only 3 input variables are there with 1 input. In that case, called the 3 cross 1. So, coming to output equation, y of t is c into x of t plus d u of t, where c is called again the coefficients of the output variable and d is called as the again a transmission between input and output. That's why c is called as the output matrix, d is called as the transition matrix. In together, to explain the state model, we require 4 matrices and 2 variables. 3 variables. The 4 matrices nothing but A, B, C, D, where A is called as system matrix, B is called as input matrix, C is called as the output matrix, D is called a transition matrix. And the variable x of t is your state variable, U of t is the input variable and y of t is the output variable. I will take one example of with respect to basic electrical system what is included in the syllabus. Let us consider an electrical system. Here there will be different elements R, L, C, etc. are connected. Some fashion is connected by some source, is a current source. There will be one source we are connected. In this case, just observe here. R is the resistance, L1 and L2 are the two inductors, C is the capacitor. The first step when you take any system to develop the state method, you should find out how many state variables are there. Now, how you can select state variable? The number of state variable in the system is depends upon the number of energy storage elements. What do you mean by energy storage element? Energy storage element out of the your passive elements, what you are calling as a resistance, inductance, capacitance. Resistance cannot store the energy, therefore it cannot be called as the energy storage element, whereas C and L are the energy storage element. Therefore in this case there are three energy storage elements, that means there will be three state equations. And how you can select the state variable? If there will be inductance, the current flowing through that inductor is the one state variable. And if there is capacitor is there, the voltage across that capacitor is the state variable. Therefore in this case IL1, IL2 and the corresponding E1 are the state variables. To obtain the state equation for that one, for the inductor, nothing current flowing to that one, you have to apply the KVL to that loop where it is connected. KVL to that loop where it is connected. And similarly, to obtain the state equation for the capacitor, you have to apply the KCL to where that capacitor is connected. Therefore, on that base, you will get the three state equations like this. And finally, you can put in the same pattern, nothing but in the form of the x dash of t, or you can take q, something, some other nomenclature I am using. Therefore, A, B, C, D. This is called a D. There is no when D will comes in picture, when there will be two inputs are there. Only one input is there, you will get D is equal to 0. Thank you.